Hi everyone, welcome back. Today we'll solve a very interesting lead code problem. It's a maximum number of the distinct element after the operation. First of all, we will understand the problem, break it down step by step, and then write the code together. By the end, you will know exactly how to think through the problems like this. So, first of all, we will understand the problem. Here we are given an integer array of nums and an integer k, and we can add the any integer between minus k and k to each element at most once. And our goal is to make the array, like here our goal is to make the array have as many distinct element as possible. Like that means for every number we can move it a little bit left or right up to the k step, and our job is to make the all the number as different as possible. So like I will give you one example. Here we have an integer array of nums and integer k2. So for each number we can add or subtract up to k, like from a minus 2 to 2, like so for 1, like we can make it any of this, like 1 is not 1.2, it is 1. Okay, 1 we have to add in the range from minus k to k. So minus 2, minus 1, 0, 1, 2. So it will become like minus 1, 0, minus 1, 0, 1, comma 2. Okay, like so for similarly to we can make it like for 2, if we subtract it like then from 0, 1, 2, 3, 4. Okay, similarly, so for 3 we can make it like similarly for 3 we can make it 1, 2, 3, 4, 5. Okay, so similarly for 4 we can make it like 4 we can make it from like 2, 3, 4, 5, 6. Okay, we can add, and now we want to pick the one number from each range so that all the final numbers are the different. So let's see how we can do that step by step. So so for number one, talking about the number one, what is our range? Our range is from minus 1, like from minus 1 to 3. So for minus 1 to 3, and here so the distinct so far will become minus 1. Okay, and similarly for number 2, like for this two, like the range is from 0 to 4. Okay, 0 to 4. So the like here the distinct so far is from minus 1 to 0. Okay, similarly we have 2, no, similarly for 2. Now coming for the this 2, our range is from 0 to 4. So the distinct so far, so what will be the distinct so far here, like minus 1, 0, and 1. Okay, similarly for like number 3, our range is from, for the number 3 our range is from 1 to 5, no, 1 to 5. So the distinct so far will be like -1 0 1 and 2. Okay, similarly for another 3, like we have 2 3, like similarly for another 3, its also ranges from 1 to 5. So the distinct so far will be like distinct so far will be -1 0 1 2 1 2 -1 0 1 2 and 3. Okay, similarly for number number 4, our range is from like from 2 to 6, from 2 to 6. So the distinct so far will become like this will be there from -1 0 1 2 3 and 4 also. Okay, so like we always pick the smallest possible number that is still available and within the allowed range. That's why we keep everything distinct and use the range efficiently. So our like final our final distinct numbers will be like -1 0 1 2 3 4. Okay, so here so the out so the output is 6. Okay, so the output is 6 because like 1 2 3 4 5 6 we have to return its count. Okay, so coming to the approach part, first of all I will discuss the approach. What are the approach we need to take? Okay, in first step, like in first step we will sort the array. Okay, we will sort the array, and second step like we will keep a variable name it as like next, like that stored the smallest number uh, we can use next. Okay, so keep a variable next. Okay, that keep a that store the what that will store the smallest number we can use we can use next. Okay, then in third step, like for each number we will have like each for each for each number like for each number we will find the smallest value we can assign within num minus k to num plus k, like that is greater than or equal to next. Like we will like find the smallest value we can assign within num minus k to num plus k. Okay, and like that is greater than equal to next. Okay, and then if it's valid, let's tell if it's valid, add it to the set and move the next to candidate plus one, like to the next number plus one. Like if it's valid, add it to a set and move next to candidate plus 1, like that is the next integer. And at last, and at step 4, like this will be our step last step, like we will return the, we will return the size of the set. Okay. So these are the algorithms we need to follow, these are the approach. It's a simple 4-step approach. Like I will comment out these all parts. Okay. Okay, now let's move to the code part. Okay, now as discussed in the step 1, we will sort the array. Okay, arrays dot, we will sort the array like nums. Okay, and in the step 2, like to store the distinct element, we will make use of one set. Okay, set integer used equal to new hash set. Oh, I think, yeah, hash set. Okay, we have to store the distinct element, we will make use of this. And in step 4, we will keep the track of the next smallest available number, like int next equal to integer dot mean value. Okay, like it is to keep the track of the next smallest available element. After that, we will make use of one for loop, like for in num in nums. Okay, like first, here we will find the smallest possible value which is greater than or equal to next within the range num minus k to num plus k. Okay, so I will comment out this part. In we will find the smallest, we will find the smallest possible value equal to, okay, next within range, like num minus k to num plus k. Okay, so int can, oh sorry, this will be small, uh yeah, int candy, oh yeah, int candidate equal to math dot max of num num minus k and next. Okay, and in this step, what we will make, like if the candidate is within the range, we will use it. Like if the candidate is within the range, use it. Like if candidate num plus k, if it is in the range, we will use it, like use dot add, okay, candidate, and we will move next to the next integer candidate plus 1. Okay, and it last step, just like we will return the number of the distinct element, return used plus size. Okay, now let's just, yeah, yeah, now let's run and see whether it's passing the given test cases or not. Arrays, okay, sorry, yeah, arrays dot, oh sorry, arrays dot sort, 1 second, yeah, int next integer dot mm, integer dot mean value, integer dot mean, what is this, integer dot mean value, int okay, next integer dot mean value, integer cannot, what is this, like integer dot mean value, okay, integer dot, 1 second, yeah, just I will clean off. What will be our next will be like integer dot mean value. Okay, now let's run and see. Yeah, here we have successfully passed the given test cases. Now let's submit and see whether it's passing all the hidden test cases or not. Yeah, we have passed all the hidden test cases as well. Like, so here the complexity will be like sorting will take like big O of n log n, and loop takes big O of n. So our the time complexity will become big O of n log n, and the space complexity will become big O of n, because we are making use of one uh, extra set. So here the main idea is simple. Like, first we sort the array, and for each number pick the smallest possible value that keeps the all number distinct and within the allowed range. Like, this greedy approach ensures we get the maximum number of the distinct element. Okay, so this was the today's problem.